Hi everyone. Today I've got a nice little problem that I'd like to discuss, which illustrates how simply rephrasing a problem can suddenly cause an otherwise quite difficult task to solve, where the solution is not clear at all, to suddenly be blindingly obvious and for the solution to really fall out quite easily. So let's jump right in. Imagine we have a ruler which is exactly 1 meter in length. And on this ruler we place 100 ants. So if I draw some of these ants as just little dots on the surface of the ruler, it might look something like this. Perhaps there's one right at the edge, perhaps there's a few very close to each other in the middle. Each of these ants have 0 length, and so they do not take up any space at all on the ruler. Now, initially, an ant can either be facing to the left or to the right. And throughout this problem, ants are either facing left or right. Now, once the problem starts running, each ant starts moving at exactly 1 centimeter per second in the direction that it's facing. When an ant reaches the end of a ruler, walking in that direction, it will fall, and it is no longer on the ruler. Similarly, if it reaches the left end of the ruler, the same happens. So as time passes, ants will start falling off the edge of the ruler. Now something else happens when 2 ants collide. That is, there is one ant walking to the left and another one ant walking to the right and another one walking to the left. That when they collide, they instantaneously bounce off each other, and the one that was previously walking to the left is now walking to the right, and the one that was previously walking to the right is now walking to the left, still at 1 centimeter per second. Now, as time passes, as I said before, ants will be falling off the end of the ruler. So the question is, without knowing the initial configuration of the ants, that is the position of the 100 ants and whether they are facing left or right, what is the least time that you will definitely have to wait in order to ensure that all ants have fallen off the ruler? And equivalently, what configuration of ants requires this length of time to wait? So, if you like, you can pause the video now, have a think about this problem, but otherwise I'm going to jump straight into the solution. So the solution goes something like this. Again, we have a ruler, 1 meter in length, 100 ants, as I previously said. However, if we simply rephrase the problem so that when a collision occurs, that is, an ant is moving to the right and another ant is moving to the left, and they collide, under the current definition of the problem, those ants will bounce off each other, and one will be moving to the left afterwards and one will be moving to the right afterwards. But that is logically equivalent to the 2 ants simply passing through each other. That is, the one that is previously moving to the left just passes through the other one and continues moving to the left. And the one that was moving to the right passes through the other one and continues moving to the right. If you have a short little think about this, you can see that this is equivalent to the ants colliding, instantaneously bouncing off each other and then walking in opposite directions. The only thing that is different is that the ants have essentially swapped position, except the ants are identical to each other except for their direction they're facing and their position. So there's no difference here if we rephrase the problem like this. So now if imagine we have an ant at some position x centimeters from the end of the meter of the ruler, and it's moving in that direction, then we can clearly see it's got x centimeters to travel until it reaches the end. It doesn't matter if it collides with any other ants along the way because it will simply pass through them. X centimeters to travel at 1 centimeter per second is going to take us x seconds to fall. And therefore, all ants will take the number of centimetres that they've got remaining to travel before they reach the end of the ruler, that is the number of seconds they're going to take to fall. And so the longest one ant will ever possibly take before it reaches the end of the ruler is the case where it starts at the very edge of the ruler facing inwards, in which case it's going to travel 100 centimetres before it falls, and therefore it's going to take 100 seconds before it falls. And that is the answer. 100 seconds is the longest you will ever have to wait to ensure that all ants have definitely fallen off the ruler. So it's quite simple. It's easy to see how a simple rephrasing of this problem, just suddenly allowing the ants to pass through each other, causes the solution to fall out quite easily. So thank you for watching, and I'll see you next time.